Hi all. Today in this video we are going to discuss about the Lewis dot structures. This topic is from the chemical bonding. This Lewis dot structure gives an information regarding the bonding in molecules and in ions. Bonding in molecules and in ions. So through what? Here these Lewis dot structure explains the bonding in molecules and ions through the shared pair of electrons, means how many electrons are shared between the two atoms, shared pair of electrons, and the second one through the octet rule. Through the octet rule. So here Lewis dot structure provides an information regarding the bonding, means how the electrons are shared between the atoms, means here it is explaining the covalent bond, and also through the octet rule. Okay, so for example, let us take oxygen molecule. For this oxygen, here there are some rules to follow to write the Lewis dot structure. The first one, step 1 is calculate the number of valence electrons. Calculate number of valence electrons. Valence electrons of the atoms for which you are writing the Lewis dot structure. Here we have taken oxygen. Here two oxygen atoms are there. Oxygen belongs to simply 6th group. So how many valence electrons are there? 6 valence electrons will be there. Or else oxygen electronic configuration 1s2, 2s2, 2p4. So here these are valence electrons. These are inner core electrons will not participate in bonding. So valence electron means 4 plus 2 6, or otherwise you just recognize the atom belongs to which group. So here it belongs to 6th group, 6 valence electrons. So here 2 oxygen atoms are there. 2 into 6, 12 electrons, 12 valence electrons. That is the step 1. Okay, and step 2, here just put a bond between all the single bond between whatever the atoms are existing in a molecule or ion. Here just put a bond between them. So here it is step 2. Step 2 is calculation of bond pairs. Calculation of bond pairs. Okay, bond pairs is equal to 2 into number of bonds. Bond pair of electrons. Bond pair of electrons. It is equal to 2 into number of bonds. How many bonds are there between two oxygens? First you write a single bond between any atom. So here it is equal to 2 into 1, which is equal to 2 bond pair of electrons. And step 3. Step 3. Now calculate lone pair of electrons. How many lone pairs are there? Lone pairs is equal to valence electrons minus bond pair of electrons. So valence electrons are 12, bond pair of electrons are 2. So how many lone pair of electrons? 10 electrons are there. Okay. So first calculate how many valence electrons are there in a molecule you are taking, and second one, second step, just put a, for example you are writing for nitrogen, you just write put a bond between these two atoms. Whatever atoms are there, just put a one by one we'll discuss the examples. So here first, as we are discussing oxygen, just put a single bond between these oxygen atom. So bond pair of electrons is equal to 2 into number of bonds, which is equal to 2 electrons, and lone pair of electrons, valence electrons minus bond pair of electrons, this is which is equal to 10 electrons. Okay, now here these lone pairs, you start here according to octet rule. Here for each atom, around each atom there should be 8 electrons. Then only it will be stable. So here how many bond pair of electrons are there? Here 2 bond pairs are there. So now here, now you start sharing these 10 lone pairs from the corner atom. Start sharing from the corner atom. So this is your corner atom. Here I am representing with 1. So 10 electrons, 1, 2, 3, 4, 5, 6, here 7, 8. So for this oxygen atom, 8 electrons are there. So octet has completed. Your job is done here. Now next come back to the second one. Here we have shared 6 electrons here. With 10 minus 6 we left with 4 lone pairs. Now 1, 2, 3, 4. Now look at this second oxygen atom, whether the octet rule has satisfied or not. So 1, 2, 3, 4, 5, 6. No. Now you just share these pair of electrons between these 2 oxygen atoms. Okay. Now after sharing this, you just write down the structure here. Oxygen, oxygen, 1 bond is there. Now here, how many lone pairs? Here there is a bond. This is the bond shared between the 2 oxygens. So here 1, 2, 3, 4, 5, 6, 7, 8. Now this is first oxygen and it is second oxygen. Now you calculate how many electrons are there around each oxygen atom. So 1, 2, 3, 4, 5, 6, 7, 8. For this oxygen, octet has satisfied. Now come to this one. Second oxygen, 1, 2, 3, 4, 5, 6, 7, 8. So this is the Lewis dot structure. How the electrons, here I told you already, this explains how the electrons are shared between the atoms through the octet rule. Okay. So here for any molecule or ion, you can follow this procedure and write down the Lewis dot structure. Okay. Don't worry, we'll discuss more examples so that this topic will be more clear to you. Okay. So the first step, calculate the number of valence electrons, and the second one, calculation of bond pairs, and the third step, lone pair of electrons, which is equal to valence electrons minus bond pair. Let us write the Lewis dot structure for nitrogen molecule. So step 1, valence electrons. How many valence electrons are there? Nitrogen belongs to which group? Here nitrogen belongs to 5th group. So 5 valence electrons, as 2 nitrogen atoms are there. 2 into 5, which is equal to 10 electrons. Okay. So just put a bond between these 2 atoms. So how many bond pair? Bond pair of electrons is equal to 2 into number of bonds, that is equal to 2 electrons. And how to calculate lone pairs? Valence electrons minus bond pairs. So which is equal to 10 minus 2, which is equal to 8 electrons. Okay. Now here these 8 electrons, you start staring between these 2 nitrogens. So here starting from the corner atom. So here first you have to start sharing these 8 electrons from the corner atom. So 1, 2, 3, 4, 5, 6, 7, 8. So octet of this nitrogen has satisfied. Now come to second nitrogen. Here we left with 6 electrons we have shared to this nitrogen. We left with only 2 lone pair of electrons. So here 1, 2. 1, 2, 3, 4. So this octet is not satisfied. Second nitrogen octet is not satisfied. Now share these electrons between these 2 atoms. So these pair of electrons, share this and share this. Now here there will be a triple bond between the nitrogens. N. So how many lone pairs? Here this lone pair we left with, and this lone pair we left with. Now calculate the octet. 1, 2, 3, 4, 5, 6, 7, 8 for this nitrogen. Okay, and here for this nitrogen 1, 2, 3, 4, 5, 6, 7, 8. So octet for both nitrogens as satisfied. So this is the Lewis dot structure for nitrogen. Okay, similarly for any homoatomic molecule you can write the Lewis dot structure like this. And okay, before discussing how to write the Lewis dot structures of ions, we'll discuss one more example, that is CO2. How to write the Lewis dot structure for carbon dioxide. So first, as usual, all the steps we have discussed for the oxygen and the nitrogen are same for writing Lewis dot structure for any molecule or the ion. But in the previous case, oxygen and nitrogen, here those are homoatomic molecules. So, but here it is a heteroatomic molecule, means it is the combination of carbon and oxygen. Two atoms are there. So you have to decide which one is the central atom now. So here what are the requirements for the central atom? So here means here among the carbon and oxygen, and the first rule regarding the central atom is central atom should be least in number, means least in count or least in number. Among these three, here it is triatomic molecules, carbon and 2 oxygen atoms are there, only 1 carbon is there, least in count. Okay, and less electronegative. So among carbon and oxygen is more electronegative obviously. And the third one here, least in count, least in number, less electronegative, or the central atom should be of large size. Okay, and the second one, hydrogen and fluorine cannot be central atoms. Cannot be central atoms because of their small size. Okay, so among these two, carbon is the central atom. Now the steps are same. First one, calculation of step 1, calculation of number of valence electrons. Carbon belongs to which group? Here carbon belongs to 4th group. So how many carbon atoms? 4 valence electrons. So here valence electrons 4 plus oxygen belongs to 6th group. How many oxygens are there? 2 oxygen atoms are there. 2 into 6. So it is 12. Altogether how many valence electrons? 16 valence electrons are there in carbon dioxide. Step 1 completed. And step 2, writing the skeletal structure. Okay, writing the skeletal structure means here, just I told you already, central atom, this is the central atom carbon, and around the central atom, this oxygen, here one oxygen and here one oxygen. Okay, first step, you have to decide which one is the central atom. So calculate the number of valence electrons, and the second step, around the central atom, these two are the corner atoms or the surrounding atoms, whatever it may be, surrounding atoms of a central atom. Now just it is the skeletal structure for the CO2, just one bond between the atoms. And step 2 is calculation of bond pair of electrons. So how many bond pair of electrons are there? 2 into number of bonds, here 1 and 2, so 2 into 2, which is equal to 4 electrons. Okay. Now calculation of lone pair of electrons. Lone pair of electrons is equal to valence electrons minus bond pair of electrons. So which is equal to 16 minus 4, 12 electrons. Okay. Now all the 3 steps, 1, 2, 3 steps are completed. We have written the skeletal structure also for the carbon dioxide molecule. Now you start sharing these lone pair of electrons. How many are there? 12 electrons. Start sharing between the atoms and start sharing always from the corner atom. So what is the corner atom here? This is the corner atom here. Already 1, 2 bond pair of electrons are there. So octet rule should be satisfied. So here 1, 2, 3, 4, 5, 6, 7, 8. Octet of this oxygen atom is satisfied. And next, second one. Second, come to this oxygen. First corners. This corner and next this corner. Here 6 electrons we have shared. We left with more 6 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen octet also satisfied. Now come to central atom. So but here around the carbon atoms only 1, 2, 3, 4 are there. What to do? Here this oxygen will share this lone pair. This oxygen will share this lone pair between the carbon and oxygen. Now the Lewis dot structure for the carbon dioxide will be here. We left with 1, 2, 3, 4 lone pairs. 1, 2, 3, 4 lone pairs and a bond. Now here, just look at this one. One bond means 2 electrons. So here 1, 2, 3, 4, 5, 6, 7, 8. Octet of this one completed. 1, 2, 3, 4, 5, 6, 7, 8 completed. 1, 2, 3, 4, 5, 6, 7, 8. Third atom completed. This is the way of writing Lewis dot structure for the CO2 molecule. Okay. You can adopt this method anyway. Okay. By using the same procedure, you can write the Lewis dot structure for any molecule. Okay. Now, next one.